Every day, an astounding 13 million visitors turn to ChatGPT's virtual doorstep.
I'm shocked.
By the end of 2023, ChatGPT will have already generated $200 million. But ChatGPT isn't alone in the AI race.
I'm not alone.
Google's Bard and Facebook's upcoming generative AI wizardry are blazing a trail in an AI arms race. Does this question ever hit your mind? What is the secret sauce behind ChatGPT and its rivals? Get ready for the exhilarating deep dive into large language models' backstory, architecture, and mind-blowing capabilities to unravel their evolution and impact on the world. So let's jump in. Before we go into how to build one, let's explore the history of large language models. What is a large language model, aka LLM? Large language models like ChatGPT can utilize deep learning and machine learning for NLP based on the user's input data. They are not only pre-trained on vast amounts of data, in fact, utilizing the techniques of machine learning and deep learning, these models can fine-tune their responses, learning from the user's feedback and sequence inputs. But why do we call these models large?
It's large enough for your needs. It's flat and firm.
The largeness of these models is accounted for by the number of parameters they contain, which are considerably huge. Thinking how large it can be? The largest known model up until now is Google's Palm, having 540 billion parameters, which is enough to fill tons of libraries. History of large language models. What do you think the story of LLM's beginning is? Was it a quick popcorn kind of deal? If you imagine that an artificial intelligence specialist just picked some concepts from deep learning and machine learning, combined them overnight, and a large language model was formed, then that's not it. It's a journey of a humble beginning from word to vec. Being proposed in 2013, word to vec differed from today's large language models. They were more a tool for machine learning practitioners to turn words into vector form. When putting words into an input dataset, these systems convert those words into a list of float numbers, which you may say, converting text into numerical form. The most exciting part about these systems is their ability to understand the semantic relevance of words. For example, king minus man plus woman equals queen. In 2017, an innovation was brought into developing large language models when Google introduced Transformer. It was a neural network architecture based on attention. Transformer has its roots deep down in the LSTM, or long short-term memory, that utilizes a neural network to introduce memory units.
Youth is no guarantee of innovation.
The Transformer was a sequence-to-sequence network in terms of input and output. The purpose of these memory units was to have long-term data storage following sequence prediction problems. For example, if you wanted to translate an English sentence into Dutch, a traditional machine translation system, such as a rule-based model, will break down this sentence into individual words, translate each word, and then combine them. It's a whole lot of work, right? However, translating the same sentence using the Transformer system will work sequence to sequence. If you input the sentence, "the dog is sitting on the mat," the output sequence in Dutch would be "de hond zit op de mat." Lastly, we all know OpenAI is the current stage of the history of large language model development. The story begins with the potential of a generative pre-training method and develops into the mind-boggling ChatGPT based on NLP that we all know and use today. ChatGPT has an LLM model with 175 billion parameters. Stunning, isn't it? But we haven't yet talked about what these large language models actually are.
Oh no, I don't think so.
Examples of what LLMs can do. Until now, we've been talking about ChatGPT, but do we have other examples of large language models? Bard AI is Google's recent LLM introduction after ChatGPT to compete with the trending NLP AI model. And when Google was taking part in this digital AI race, how could the owners of Meta sit quietly? Being a transformer-based model with variable parameters, Llama is designed by Meta to help research in their research process by utilizing the deep learning and machine learning possibility of this large language model. Llama stands for Large Language Model Meta AI. It works on a neural network based on billions of variables and models of the human brain. The exciting part is that you can never use Llama as a chatbot for convenience. Don't you think that information about LLMs is incomplete without knowing its use cases? So, large language models can be used for translating texts into multiple languages, increasing the relevancy of responses in search engines, assisting customers on e-commerce and other websites using NLP, generate rapid advertising, informational and multiple types of content, sentiment analysis or entity recognition for classifying text for different purposes like advertising, getting help with educational tasks, and getting feedback on written assignments. Have you ever thought about how these LLMs do their wordy wonders? Curiosity didn't just kill the cat, but this time it birthed the amazing algorithmic models. So let's take an LLM-sized leap into this working process.
I'm really excited.
How do they work? Let's break down the process into steps to make it easier to understand. 1. Tokenization. The magical process of large language models begins with tokenization. It's the division of text sequences into smaller, meaningful units or tokens. Using NLP in a better way relies on it since it helps LLMs understand text data complexity. You can imagine tokens like letters in crossword that help make a complete word combining alphabets. 2. Embedding. This involves turning tokens into meaningful vectors to encode the semantic meaning of words in the input text sequence. Embeddings are pre-trained using neural language models that include predicting the next word in the sequence. An LLM can store embeddings for help in future NLP tasks. So this step is not only part of language processing, but also adds up to learning LLMs. 3. Attention. Ever wondered why you get the exact response you need from an artificial intelligence model? As the name implies, attention is the model's focus on essential parts of the input sequence. How do LLMs deal with it? Transformer-based models pick up the dot product between two tokens. These dot products result in a matrix of weights, giving the importance of each token, and then the most important ones are picked up to respond. That's how LLMs respond to you with the most relevant answers. 4. Pre-training. Pre-training is actually a developmental process of large language models, but it's a huge part of how they work. Before developing into fully fledged AI models, these language processing systems go through pre-training to encounter the mountains of text for mastering the language intricacies. During their development, these models are trained on a large corpus of data to help them understand the syntax, semantics, and context of the input data. Multiple architectures are used for the pre-training of large AI models, which includes transformers, autoencoders, and recurrent neural networks. Have you ever seen our video on Sophia the AI robot? If not, then you must glimpse through it because she wasn't introduced into the market without pre-training. It took her some days to understand the language of humans and how to respond to it. 5. Transfer learning. Finally, the AI model utilizes its pre-training combined with tokenization, embedding, and attention to respond to a specific smaller amount of data. GPT was trained on multiple amounts of data, but when you give it a prompt, you get a relative response in return instead of unorganized data. So that's how large language models streamline their working process to give you the best possible answers to your queries. Let me guess, your mind is already getting into things fast-paced, and now you want to know the building process of LLMs, so let's begin with it.
All right, gentlemen, let's begin.
How are they built? Getting ready to make your own LLM and fill your bank with money? Not yet, AI enthusiasts. If you think that you can just watch this segment and you will be able to build a large language model, then you're wrong because it's a complex task requiring computational resources and expertise. So why are we talking about this here? To let you understand what it takes to make a large language model. 1. Processing of data. First, we need the main ingredient of the recipe, and that's data that we will put in the large language model. This can come from brainstorming, classification, closed QA, general information, open QA, and summarization. However, this data should not come from any other AI model or web browsers. 2. Training large language models. Subword encoding techniques and tokenization is required to train the model on collected data. When ChatGPT was being trained in the first step, it was incorporated with enormous parameters of data in a controlled environment. Yet, during the second phase, it was trained through unprogrammed data using a GPT-3 trained procedure variant. The model is also optimized during data input utilizing gradient checkpointing and mixed precision training. 3. Testing the model. Once the model is trained, now is the time to test it. Techniques like perplexity and human evaluation can help with an outclass evaluation of the model. Perplexity is utilized to determine the quality of a language model by inquiring how well a language model can predict the following words in a sequence. 4. Collecting feedback. User surveys, usage metrics, and error analysis help assess the professionalism and ability of an LLM. Without feedback, a language model is nothing. Because if you don't know what it's doing right, will you be able to improve it? Of course not. What's the future of LLMs? Moving on to the future of LLMs. Can you picture LLMs having their own Benjamin Button moment? Imagine in the near future we might refer to LLMs as small language models, as if a witch casts a spell on a grown-up who then shrinks into a little baby with even more powers. The future is focused on reducing the size of these language models, giving them quality data instead of scrubbing the whole web. But why is that so? Is it difficult for artificial intelligence to handle such huge data? Of course, it's not difficult, but having that amount of data affects the quality of responses generated by these large language AI models. From a financial point of view, training one large language model requires a couple of $1 million to $10 million. That is huge, right? When Google Chrome and Microsoft Edge already offer a large amount of data, why spend millions of dollars designing artificial intelligence language models? Creating compact language models in the future is super important so that when a user submits a prompt to ChatGPT, it doesn't need to assess 175 billion parameters to deliver one answer. The AI team of Meta is researching methods to create smaller LLMs utilizing sparse expert models. These sparse expert models use a fraction of the compute to respond to the user's prompt. Companies like Alpha, Fixie, Stability AI, and Lighton have already released the first testing smaller models of LLMs. So the future progress of LLMs is already near. Is the astounding potential of large language models worth putting in all the thought processes and construction challenges they present? Do you believe that there's a world of possibilities waiting to be unleashed with these LLMs? Hit the subscribe button and don't forget to give it a thumbs up if you enjoyed this intriguing video. And if you're interested in diving deeper into the inner workings of the game-changing ChatGPT, then leave a comment below to signal your curiosity.